afternoon, everyone. Today we'll be discussing number sense. And oddly enough, when Anita came up, she was helping us with our technical difficulty. And the professor asked her, isn't it shorter to go this way than that way? And I wanted to tell her, use your number sense.
But you're not hitting the arrow. Knuckles. No, it's not working.
Use the arrow when you
Yes, but if you're
The board?
anywhere. Twice.
Do it from close over here. Okay. Wow. Okay. So we started with a problem. Basic problem that all of you guys should be able to solve, so I'm going to ask you all to solve this problem. Casey wanted to buy a sweater that cost $50. She has 15% off coupon. How much will the sweater cost before taxes? You get
$42.50.
Okay, now how did you get that answer?
I divided, I found 10%, which is $5, and then I multiplied that by 1.5, which is, oh boy, which is 7.5, and then I subtracted that from 50.
Okay. Sorry. One more. I learned to draw on there, but I don't think it'll come up. So you found 10%?
10% of 50,
10% of 50, which is what?
$5,
Okay.
and then I multiplied it by 1.5,
Okay.
which is 15%, so it's $7.50.
Okay. That's right. Did anyone get the same answer but get it a different way?
I multiplied 50 times 0.15,
Okay.
which would be 50%.
Okay.
And I got 750, so then I subtracted that from 50.
Okay. Anyone get it a third way? Okay, so a third way could be, I know that if I take 15% off, I'm taking 15 cents off for every dollar, so that means 85 cents to the dollar, so 85 times 50 would also give you the same answer. So this is number sense. I solved it one way, Anita solved it another way, we solved it 3 different ways. You could probably come up with 12 different ways to solve it because we all have a different sense of how we're going about numbers. So that brings us to our definition. Which is supposed to, what is number sense, which drags out.
okay. We can't see from on this side. Number
Yeah,
sense.
get closer.
Oh, thank you.
It won't bite you.
Okay.
Number sense is this. Number sense in the school environment is an understanding that allows students to approach concepts, ideas, and problems concerning numbers differently, according to their backgrounds, experiences, and studies. Number sense, I said also, is woven in the curriculum. And just like I used the example with Anita this morning, it's an innate, almost innate, intuitive sense of numbers. Facts about number sense. Number sense starts to develop, it's said, around the age of 3. Number sense can be found in many different areas of math. That includes number lines, like linear equations, fact families, addition, subtraction, and math properties, such as problem solving. Working with manipulatives can help students to have a strong sense of numbers.
So pretty much number sense, it's not like most math subjects. It's not like you start learning geometry in 2nd grade. Number sense is always kind of building. So even now we're building our sense of numbers and we want to learn as much as we can to broaden our number horizons. So number sense to develop effectively is, I think, what we've been learning all year. It's, you don't want to teach one way to do a problem. You want to teach 4 ways to do a problem, because that one way might not work for you, but it'll work for her, and so on. So since number sense isn't really very specific to one subject, we kind of just did some history on a few things. So we looked at Egyptians in base 10, India, and how they have the concept of 0 and negative numbers, and that's kind of something that you have to develop to, as you develop in math, you learn about negative numbers, and that's kind of a hard concept at first. How do you have negative of something? And that's something that develops over time. Also, the Chinese and the abacus, in kind of developing that, what we're talking about when they say 3-year-old. When you first talk about numbers, it's 1, 2, 3, and kids are counting, but they're not really understanding what that necessarily means. And then they learn 1 is 1, and 2 is 2. So then that brings us to our first activity, which we're just going to talk about.
This activity, what you would introduce is the idea of creating your own number system. And most children probably think, well, how am I going to do that? And why would I do that? Because we already have a numeric system. Well, what you would tell them is that there are tables that explain symbols that were used years ago, and I'll go into that in a moment. Then you use the system to write your age and the year you were born. And what I discovered, and I was sharing with Eileen, is that the history of numbers spans thousands of years ago when symbols were used to represent numeric values. And if you look, let's see which one I'm going to use. This is an arch, and these are lotus. Let's see. This is a coil, and these are strokes. It was difficult to find some of these symbols on the computer, but if I used this arch, each arch is, the value is 10, and each stroke, the value is 1. And if I said that my age was equivalent to 4 arches and 6 strokes, how old am I? Yes?
46.
Okay, so in essence, the children would be able to create their own symbols, establish a table, and solve the problem.
Our second activity is called Magic Squares. So in front of you, you guys all have numbers 1 through 9 and a 3x3 grid. So Magic Squares was originally from Chinese culture, and they used to think of them as actual magic. And you set up your own table, and you're supposed to make it so that all the rows and columns equal the same number. So, for example, A, B, and C will equal the same thing as D plus E plus F will equal the same thing as G plus H plus I, and so on down. So if you cut out the numbers you have in front of you, I want you guys to try and make a magic square, and then we'll talk about it. I'll give you a hint since we have limited time. The middle number will always be 5, and there's not just one answer. You can work in twos if you'd like. Well, you want to make it so that
horizontal,
Yeah.
diagonal, and vertical
Has the
all
same
add up
sum.
to that one.
So does anyone have any ideas about what numbers they might try together in order to get the same sum? Or does anyone have an idea about how to figure out what number we're getting to?
I would look at numbers that add to like maybe 10 or something, so match the 1 and the 9, and then move it around and see if that works. So like kind of patterns like that. So then 1 and 9, and then 2 and 3. Or
Right. So
2, 7, and 3.
Anita's definitely on the right track. So if you're finding numbers that you want to be the same, you want to mix numbers that are different. So you want to not mix high numbers with low numbers, and then you have middle numbers in there. So I don't know what to do with those.